In today's lesson, we are going to be looking at factoring special trinomials. So this lesson is going to be more of a shortcut for some very specific trinomials. You can still use the previous methods of solving or factoring trinomials with these ones. We're just going to be looking at some specific scenarios or looking at some unique characteristics that will allow us to kind of shortcut the entire process. But again, if we forget the process, then it's fine. As long as you remember how to factor simple and complex trinomials, you can use that same method for these ones. So just as a warm-up, we want to expand the following. And as we expand them, we're going to take a look at the result and see, is there any sort of relationship between the final product and the factored form. So I'm going to use the FOIL method or the rainbow method distributive property. X times x, we get x squared. X times 8, we get plus 8x minus 8x, and then we get minus 64. I can go through and collect like terms, which would be my two middle terms. I get x squared, 8x minus 8x is just 0. It cancels out. So x squared minus 64. Right. So what do we notice about this final product and then the factored form that we started with? Right. Well, we have our x squared, and that's first. We have 8 and 8. Well, 8 squared is 64. And then we just have two terms because that middle term is gone. So we should kind of recognize or see some sort of kind of characteristic. And we did have you had a few more warm-up questions with some of the in a previous page. But looking at it, we should recognize that, or start to see that the final value, or the second value, when we take the square root of that, it is the two answers or the two values in both my brackets, and then x squared, again, the square root of that is the value of the first part of both brackets. And the only difference between them is one is subtracted and one is added. Now, this might seem familiar to you. This is something that you would have looked at in grade 10, so this is a little bit of a review. If I look at b and want to expand this, we'll have x plus 4 squared. Right, so that just means x plus 4 times x plus 4. And again, I can use rainbow method, FOIL, distributive property, however you want to call it. And we are going to expand this. So x times x is x squared. We have 4x or plus 4x plus 4x plus 16. I do have like terms that I can combine. So I'm going to have x squared plus 8x plus 16. Is anything about this form or this final product or final trinomial that I can see in kind of in the form of the factored form? Well, again, similar to the last one, we do have a middle term here. The 4, well, 4 is the square root of 16. X is the square root of x. So this is a little bit different than the last one, but we do see kind of the square roots of some of these values in our trinomial that does kind of appear in our factored form. So similar to that, we're going to go through and we're going to factor the following. So we're going to look at two different forms, and we're going to try to see if we can kind of come up with some shortcuts to help us out. So if I want to factor the first term, right, x, or the first expression, x squared minus 121, if I do it the old way, looking for the product and sum, I'm looking for two numbers that multiply to negative 121, because this would be our a, this would be our c, our b value isn't there. So our b value, the only number that we could add or subtract that we don't see, would be 0. So we're looking for two numbers that that multiply to negative 121 and add to 0. And now in this case, because they have to multiply to a negative number and add to 0, one should be positive or negative and one should be positive. And in order to get them to cancel each other out or become 0, they have to be the same value. So an easy way we can do this is saying, okay, what times itself is 121? Or we could take the square root of 121, which would give us 11. So if I go through and I factor this, based off the old method, well, I would have x plus 11 and x minus 11. Is there an easier way that I can kind of go through and factor this rather than going through these steps? And what we're going to start to recognize is in these forms, when we have two terms, and if there's something unique about both of those terms, there is a quicker way to do this. Right, and what we're going to do now is let's take the square root of the first term. Let's take the square root of 25x squared. In this case, the square root of 25 is 5. The square root of x squared is x. Let's also take the square root of 49. The square root of 49 works out to a nice number. It works out to 7. So if we have something like this where the first term is a perfect square and the second term is a perfect square, and there's only two terms with a subtraction in the middle, this is called what we call a difference of squares. And we can write this out. We're going to put the first term, the 5x, at the front. And we're going to put the second term, the 7, at the end. And the only difference in between them is one is going to be minus and one is going to be plus. And that's the quick way to factor these types of expressions. And we're going to do a summary at the end to kind of talk about what we have to look for specifically when we go through and to know when to use this kind of method. If we forget how to use this method or we forget the process, again, treat it like what we did in the first one. That middle value is 0. So what two numbers multiply to one of them, multiply to the last value, but add to 0, and you can work through it that way. But it's really going to become really helpful if we start to recognize these patterns. Looking at another set, we're going to go through and factor these ones. Now these ones might be a little bit more, we might be a little bit unsure of what to do, or looking for the pattern or kind of the shortcut because it looks like a trinomial. It looks like what we've been doing before. So let's go through and factor it as such. Two numbers that multiply to 64, but they have to add to negative 16. So multiply to 64 and add to negative 16. We go through our multiplication table and we should find that we have negative 8 and negative 8. All right. So we're going to split up that middle term into negative 8x and negative 8x. We're still going to have the x squared and the plus 64. We're going to factor or common factor our two parts. So we're going to common factor, I can take an x out of the first one. I'm left with x minus 8. Our goal in the second bracket should be to get x minus 8. And the only thing out that I can really factor out is a negative 8. I do have the same two brackets, so I can factor that out, x minus 8. And the leftovers is x minus 8. Because I end up with the exact same bracket, I can just rewrite this as x minus 8 squared. Now again, is there a quicker way that we could do this? Instead of going through this whole process, is there a quicker way? And if we take a look at it, we should recognize, well, wait a second. The square root of 64 is 8. 8 times 8 is 64. 8 plus 8 is 16. Right? So we do see the square root of 64 is equal to 8. So that might be an indicator of what we have to do. Right? And where does the negative come from? That might be the other question, right? The x I can see, that's the variable, that's the first term. The 64 is the square root, or the square root of 64 is 8. Okay, I can see that. Right? Where does the negative come from? Well, there's only one negative in our fraction, or not our fraction, in our expression, and that comes from the equation. So there is actually a quicker way that we can do this. Right? We can take, or we can double check the square root of each term. So I can take the square root of 4x squared, which would be 2x, and the square root of our last term, which is 10, or 100, which is 10. And from this, I have enough information to go through and write out my factored form, which in this case would be 2x plus 10 squared. And we're going to talk about what to look at, what to look for, and what to look at to kind of go through this. If we didn't know or recognize this pattern, we could go through and do the same thing like what we did in previous lessons. The product, two numbers that multiply to 400 but add to 24. Right, so that might be a little bit more challenging, but let's see. So that, again, it might be a little bit more challenging looking for those two numbers. And looking back, this is definitely going to be difficult because I actually have the wrong middle term here. So the middle term here should be 40. That will help a little bit. Because now two numbers that multiply to 200 or to 400 but add to 40, we get 20 and 20. Right, so if I were to go through this process, let me just kind of remove this, bring this down, break up this middle number into 20x plus 20x. We still have the 4x squared plus 20 and then plus the 100. Common factor, we can take out a 4x. We get x plus 5, or x plus x plus 5, and then we can take out 20x. We get, not a 20x, a 20, and then we get x plus 5. So we have x plus 5 times 4x plus 20. Right, this is a little bit different. So this is kind of one of the, maybe not the greatest example, but if we were to go through and factor this even further, we could take a factor of 4 out here. If I take a factor of 4 out of the second one, I have x plus 5 times x plus 5 times 4. Right? It does work out to the same thing. So this is a little bit of a weird example because there are different ways that we could write it, or technically we could factor this bottom part further. But it is still what we consider a perfect square trinomial. So there are different ways that we can go through and factor this. And we're going to try to look for those patterns. So just as a summary, and I know the last one wasn't the greatest example, but we did have other examples that we've looked at, and this should be a little bit of a review anyways. So we have a general trinomial, right? Ax squared plus bx plus c. And there's two unique situations that we can come across. One, when we're dealing with a perfect square trinomial, right? And what we do here is we take the square root of a and take the square root of c. Right? So we take the square root of a, and we take the square root of c. So we have the square root of a with an x. We're going to have the square root of c for a second one, and then the sine of b. Whatever the sign happens to be for the b value is going to be the sign that goes in the middle. And it's going to be this bracket squared. So take the square root of the first term, square root of the last term, the sign of b goes into the middle, and then that is our perfect square trinomial. And that's kind of the shortcut. Now, what to look for? What do we want to look for? How do I recognize a perfect square? Right, so there's a couple things that we have to look for, but the main thing is ax squared is a perfect square. C is a perfect square. So basically that a perfect square just means that I can square root that value or that number and get a nice answer. It's going to give me a nice whole number. It's not going to give me a decimal or an irrational number. It's going to give me a nice whole number, right? So your perfect squares might be, say, like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So all of these are perfect squares. So anytime we see these values, our mind should start to think, okay, does it fit these patterns? Is it a perfect square trinomial? Right? Obviously, there's more 5 squared, 6 squared, 7 squared, and so on. But these are just some ideas of what to look for. So aside from the first and the last term being perfect squares, there is one other thing that we need to check. And the other thing that we need to check is that we have to make sure that if we have to check to see that the square root of a times the square root of c doubled, or times 2, has to equal b. Or another way we could think of it is we take the square root of a times c. So we multiply a and c together and then square root them. And then we double that. Does it equal b? So we do have to double check to make sure that the middle term is the square root of a times the square root of c doubled, or times 2. So that is that extra thing that we do have to check, aside from the first and the last term being a perfect square. For a difference of squares, it's going to be very similar in the fact that we have to take the square root of a and the square root of c. These are going to be our two values in our brackets. However, our two brackets are going to be different. We're going to have two separate brackets. They are going to be different. One is going to have a plus and one is going to have a minus. Right? So there is going to be a difference between the two. It's going to be the same two values, right? The square root of your first term, the square root of your second term, and then inside it's going to be one a plus and one a minus. And again, the a and the c, that's coming from this general form up here. What to look for when we're dealing with different squares? So a couple of things that we're looking for. Easiest thing to look for, there's two terms. So there's only two terms, right? It might be something like a squared minus b squared. That's it. So the two terms, there's subtraction between the two terms. So there's two terms, they are subtracted, and the other final thing is that a and c are perfect squares. So again, going back, it's those perfect squares, the 1, 4, 9, 16, 25, and so on. So the main thing from this is just that we are looking at, or we're going through, starting to try to recognize these unique scenarios, because it does make factoring easier. If we don't remember how to factor, or if we don't remember these specific scenarios or these kind of shortcuts, as long as you remember that your basic steps to factoring a simple or a complex trinomial, similar to what we've done in the previous lessons, you can always revert back to that. Right? This is just a shortcut to make it a little bit easier, a little bit quicker for some specific scenarios.